All right, I am going to try something tonight when I sort of have a voice and record this notes video in case tomorrow I cannot do that. That way we have a way to do the notes. So 8.1 is all about the Pythagorean theorem, which something that you already know, especially the first parts of this notes, should be very much review. Then we are also going to be talking about specific kinds of right triangles. We call them special right triangles. 45, 45, 90, and 30, 60, 90 are the kinds we're going to be looking at today. And that's going to help us sort of make a bridge to 8-2, which is a really important section about the introduction of trigonometry into our math. So, of course, with the Pythagorean theorem, we know that that is going to be a squared plus b squared equals c squared. And we know that it means if we have a right triangle, this will be the relationship of the side lengths. However, there is also, sorry, I got to get my cat off the table. There is also a converse to the Pythagorean theorem that tells us if the sides of a triangle are related by a squared plus b squared equals c squared, then the triangle is a right triangle. So we can use the relationship there to prove that a triangle is a right triangle. If the side lengths are related in a way that the a squared plus b squared sides equal the c squared side, then we know that the triangle must be a right triangle, even if we didn't know it at the beginning. We're going to skip these next two for now. Example 1 is a video from Savas, so I'm going to put this one in. I'll link it somewhere, or I'll show it to you all together in class. So we'll say link on Schoology for now, or I'll show it to you in class. So nothing we need to think about right now, because there are lots of ways to prove the Pythagorean theorem. This is just one of them, using altitude and hypotenuse theorems, actually. We're going to come down here, and we're going to use the Pythagorean theorem. So we've got this: to satisfy safety regulations, the distance from the wall to the base of the ladder should be at least 1/4 the length of the ladder. So this distance right here, 2.5 feet, should be at least 1/4 the length of the ladder. We want to figure out if Drew set up the ladder correctly, which means, of course, that we're going to need to find the length of the ladder. We know this is the right triangle because it is between the floor and this vertical wall. So we'll use 2.5 squared plus 9 squared equals c squared. And we will solve the Pythagorean theorem for that one. I have to use a phone calculator. I was not prepared for this. 6.25 plus 81 equals c squared. So we end up with 87.25 equals c squared. And since we started with a decimal, we are allowed to put our answer in decimal form. We don't need to worry about simplifying square roots because we just have decimals all the way down. So if I take the square root of this, let's see, watch me try to use an iPhone calculator for the first time. There we go. That's going to be 9.34 as the length of the ladder. So what we need to figure out is that at least or more than 1/4, or I guess we want to figure out what 1/4 of this is. So 9.34 divided by 4 is going to give us 1/4 the length of the ladder. That's going to give us 2.33. So we ask ourselves, is the ladder set up correctly? Is this amount at least 1/4 the length of the ladder? 2.5 is more than 1/4 the length of the ladder, so the ladder is set up correctly. The ladder is set up other way we can use this is using the inverse, or the converse rather, of the right triangle theorem. And that's going to tell us that we can use the Pythagorean theorem to decide whether or not we are able to have a right triangle. So we look at this triangle in our diagram. We see that the shorter two sides are 12 and 35. They're going to become our A and B. 37 will be our C. So we're going to check. Does 12 squared plus 35 squared equal 37 squared? And we're going to figure that out. We've got 144 plus 35 squared is 1,225. 37 squared is 1,369. On the left, when we add up 144 and 1,225, we get 1,369. So we can find out that yes, indeed, a squared plus b squared does equal c squared, which means this must be a right triangle by the converse of the Pythagorean theorem. So yes, by the converse of the Pythagorean theorem. All right, and that's going to be it for video 1, because I'm going to go rest my voice and then go into the special right triangles.